mathematics lesson. I am Skolile Ngove, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, in this lesson, grade 10s, we are going to look at the surface area and volume of prisms. What are prisms? What type of 3D objects are prisms? Okay, you have to remember that, isn't it? Because we have 3D objects which are not prisms. Okay, in this lesson we're concentrating on what? On the prisms only, the surface area and volume. Let's be ready for our lesson, grade 10s. Make sure that you have your book with you and your pencil, your calculator. We are going to be doing a lot of activities. Let's be ready. Right, let's start. So we have our objectives. At the end of the lesson, you should be able to solve problems involving surface area of prisms. We're going to solve problems involving surface area of prisms. And then we're going to calculate the volume of prisms, okay? That's what we're going to do in this lesson. We have done these two in the previous grades, not in grade 9 only, even grade 8, grade 7, we have done area and volume. And we know the 2D shapes and also 3D shapes. So the knowledge about these is going to assist us a lot in this lesson. Right, as a baseline activity, I want us to try this. Right, tick the objects, 3D objects that are prisms here. We have A, B, C, D. I've given you an example here. Okay, that's a prism. Right, is A a prism? B a prism? C, is it a prism? D, is it a prism? 1 minute. Let's tick the ones which are prisms. Right, welcome back. Now, A, this is a prism. Okay, we're just stating if it's a prism or not. We're going to discuss later. This is a sphere, it's not a prism. Why is sphere not a prism? We're going to find out. And then this is a pyramid. Pyramid is not a prism. Why is pyramid not a prism? Okay, you're going to find out very soon. And then this is a prism. A prism. Right, let's discuss now. Why are other 3D shapes categorized as prisms while others are not prisms? Let's discuss this. Right. Prisms have a pair of congruent faces. Right, which we call them bases. We call them bases. So if I'm talking about the base in this lesson, you are going to understand what I'm talking about. So prisms have a pair of congruent bases that are parallel to each other. What does congruent mean? Congruent means these two shapes are exactly the same. Okay, I have objects here that we're going to use to explain this thing called prisms. Right, I have this object here. I hope you can see it. Right. If you check this side, what do you see? We have how many sides? 1, 2, 3, 4, 5. Is it 5? 6, should be 6. 1, 2, 3, 4, 5, 6. There are 6 sides. What do we call this shape? This 2D shape with 6 sides. It is called a hexagon. Okay? Then if I turn it around, and then you check this side, what do you see? You see another hexagon. So this side we have a hexagon, this side we have a hexagon. So these two shapes are congruent. So these are the two congruent faces we are talking about. Hexagon this side, hexagon this side, which are exactly the same. And then these two congruent faces, they are called bases. So this is the base, this is the base. And then these bases are parallel to each other. Remember parallel lines. They are parallel to each other. They are parallel to each other, means that they are equidistant from each other. The distance from there to there, the distance from there to there, the distance from there to there is just the same. They are equidistant from each other. That's why they say these two bases are parallel to each other. They are called what? The bases of the prism. So when I'm talking about the base of the prism, you must understand what I'm talking about. This is another good example of a prism. What we call this? I'll come back to this one. What we call this? It's a rectangular prism. Because if you check the side, it should be a square, but let's call it a rectangle for now. Right? If you check the side, you can see it's a rectangle. If you check the side, you can see it's a rectangle. So prisms are named after using their bases. So the base here, or the bases here, are the rectangles. So this is a rectangular prism, right? This one, the bases here are hexagons. So this is a hexagonal prism. Hexagonal prism because of the bases there. Right, let's check the pyramid. Right, this is the pyramid. If you check this side, what do you see? You see a square, isn't it? But if I turn it around and then this side, we just see the vertex. We don't see a square. So this is not a prism, because a prism, if it's a prism, must have a square this side, and if I turn it around like this, I must also see a square. Okay? So this is not a prism. It's just a 3D shape, which is not a prism. So you must understand what prisms are. So prisms have a pair of congruent faces, which are called bases, that are parallel to each other. It is very, very important for you to understand that. Okay? And then now this is the base. Let me use the hexagonal prism to explain the characteristics of a prism. So we have the polygon this side, and then we have the polygon this side. It is very, very easy to draw a prism. It's the easiest thing to do. Just draw your base and draw another base. Just two of them. One base, another base. And then what do? You just join those two bases with a straight line, with straight lines. You've drawn your prism. It's very easy to draw. So now we just join these. You see, like this. That's the prism. Okay? And then, like this one, we have a triangle, and then another triangle, then join them using straight lines. We have drawn a triangular prism. Very easy. Okay? Rectangular prism. Just draw a rectangle, draw another rectangle. These are two bases. Then join them like that. You see? It's very easy to draw a prism. Bases, then join them with straight lines. Okay? Remember our WhatsApp line, grade 10 063 508 1301. Let's discuss during the lesson, okay? If there's any question or any input, please let us know. We're waiting for your questions. We're waiting for your input. This is your lesson. You must understand. Make sure that you understand. If there's something you have missed, let us know so that we can discuss. And then what else? We want to talk about the bases. Oh, the bases are perpendicular to the rectangular lateral surfaces. Lateral surfaces. Right. This is the what? This is the face, and then this is another face. Now, between these two bases, what do we have? We have, you see, a rectangle, another rectangle, another rectangle. There are 6 rectangles around this. So these 6 rectangles They are called lateral surfaces. So the bases, this is the base, this is the base. They are perpendicular, meaning that the angle between the lateral face and the base is 90 degrees. The angle between the lateral face and the base is 90 degrees. So the bases are perpendicular to the rectangular lateral faces. So prisms have rectangular lateral faces. All of them, you will see that. Okay, all of them have rectangular lateral surfaces or faces is fine. The base of a right prism is a polygon, can be a polygon. Like I said, hexagonal prism, rectangular prism. You can have triangular prism, you can have pentagonal prism, octagonal prism. Okay, so that's how we name the prisms. Right, now we've discussed what a prism is. Now let's look at this one. What type of a prism is this? It's a triangular prism, because you check at the front, you can see a triangle, and then you can see another triangle that's the other side, and then these two polygons are joined by straight lines. So this is a triangular prism. So how many faces is a triangular prism composed of? And then name the 2D shapes. How many faces? And after that, name them. If there are 4 rectangles, just say 4 rectangles. If there are 5 triangles, say 5 triangles. If there's 1 triangle and 4 rectangles, right? 1 triangle and 4 rectangles, okay? All right, let's do that in 2 minutes. Right, welcome back. Do you see that a prism is made up of 2D shapes? A prism is made up of 2D shapes. Like this triangular prism is made up of what? Of how many rectangles? 3 rectangles and 2 triangles. Let's name the triangles first. We have triangle ABF. Do you see that? We have triangle ABF and we have triangle DCE. We have 2 triangles. And then we have rectangles. How many? A, B, C, D. That's rectangle 1. And then we have A, F, E, D. That's second rectangle. And then we have B, C, E, F. That's the third rectangle. So it is very, very easy to find the surface area of what? Of a prism, because we know how to find the surface areas of what? of 2D shapes, of triangles, of rectangles. We know how to find those surface areas, isn't it? So it is very, very easy to find the surface area of a prism. You just find the area of each 2D shape and then we add them. Okay, although there are formulas, the formulae that we can use, I'm going to show you. Right, given a hexagonal prism, even for hexagonal prism, I'm going to show you there's a method that you can use to find the surface area of these ones. It's very easy. Right, identify the bases. I think we have talked about the bases a lot. What about the lateral face surfaces? And then the height of the prism. That is very, very important. Okay, we need to understand especially the height of the prism, because we may have the height of the base. There's a difference between the height of the base and the height of the prism. Okay, right, now these are the bases. We've talked about that. We need to re-emphasize that. And then the lateral faces. Now these are the rectangles. The rectangles that join the bases. These are called the rectangles. Okay, so these are the lateral faces. So in this shape or in this 3D object, there'll be 6 of them. These are the lateral surfaces. And then one important thing that we need to understand is the height of the prism. What is the height of the prism? It is the distance between the 2 bases. We have the base and then the base. Then this distance between them, that's the height of the prism. Okay, let me try to show you the difference between the height of the prism and the height of the base. Height of the base using the triangular prism. Let's say we have a triangle. And then we have another base here, which is a triangle. Right? And then we join them. That's our prism. And then that's our prism. Okay? So we are going to have the height of the base, which is the height of the triangle here. This is the height of the base. So we use this height, small h, to find the area of the base. Remember, area of a triangle is half times base times height. And then there's this distance from there up to there. In some books, we use the capital letter H. That's the height of the prism. That's the height of the prism, the distance between the 2 bases. So if I'm saying the height of the prism, I mean the distance between the 2 bases. It's not like, oh, the shape is always going to be like this, where the height is like this. No? It can be like this. Still, this distance, even if it's horizontal like this, even this distance is still called the height of the prism. Okay, if it's like this, this is the height of the prism. If it's like this, this is the height of the prism. If it's like this is the height of the prism. Okay, the distance between the 2 bases. I'm trying to emphasize this so that when we get to the calculations, it becomes very easy for us. Okay, remember our WhatsApp line 063 508 1301. Right, and then this is the face. I think we've talked about that. And then where the faces meet, we don't talk of the size when it comes to 3D objects. We have faces, edges, and vertices. Right, and then where the faces meet, that's the edge. This whole thing is the face, and then the edge. And then this corner here, we can have 2 or more edges meeting them, is called the vertex. It is the vertex. Remember that. So when I'm saying vertices, edges, faces, you must know what I'm talking about. Okay? All right. Now, we are going to move together here. So I'm explaining things, but remember, I always give you work to do. You try to be ahead of me, okay? You try to be ahead of me. Right, given the following rectangular prism, we know now why we call it a rectangular prism, because the bases are rectangular, okay? Remember, rectangular prism can even take it like this and say, this is the base, this is the base, and then this is the height of the prism, or even take it like this is still fine. So how many rectangles make up the rectangular prism? And then after that, I want you to name them. How many rectangles do you see in this rectangular prism? After that, name them. When I say name them, I can give you one example. Like this one. This rectangle is ABCD. That's rectangle ABCD. Okay? So answer the question. How many do you see? And then after that, name them for 2 minutes. Let's try. Right, welcome back, rectangles. Let's see. How many rectangles did you see? Or how many rectangles are you seeing here? We are seeing 6 of them. 6 rectangles. Right? Let's name them. The first one is said A, B, C, D. So we have A, B, C, D. And then opposite A, B, C, D on the other side. The one which is congruent to A, B, C, D is G, H, E, F. G, H, E, F. This one. Okay? So the one on the left and the one on the right. Then there's one on the at the front. At the front, we have D, C, E, F. D, C, E, F. Right? And then at the back, we have A, B, H, G. A, B, H, G. These are congruent also. They are just the same. So it means if we have managed to find the area of DCEF, then we have found the area of ABHG. You see that? Okay. And then the one at the bottom, BCEH. And then the one at the top is ADFG. ADFG. So these are the 6 rectangles that are found in this rectangular prism. Okay, so we're going to use this when we're finding the surface area of a rectangular prism. These two are just the same. So the area will be just 2 times area of ABCD. These two are just the same. Area, we can say 2 times area of DCEF. And then these two are just the same. We can say 2 times area of BCEH. Okay. All right. Let's move on to the next part. Name all the edges that have the same length as CE. Name all the edges that have the same length as CE. I'm going to give you 1 minute for each of these questions. Right, 1 minute. Let's do that. All right, welcome back. So we can see that CE, even DF, is 30 centimeters. DF is also 30 centimeters. Then AG, 30 centimeters. AG is also 30 centimeters. And then BH is also 30 centimeters. So DF, AG, BH have the same length as CE. That is very important to understand, because how do you find the area of ABHG, for example? Okay, you have to know that AG there is 30 centimeters and BH also is 30 centimeters. We need also to find the length of AB and GH, okay, in the next questions. Right, name all the edges that have the same length as EF. This is EF. Name all the edges that have the same length as EF. 1 minute. Right, welcome back. So 15 centimeters DC or CT, this is 15 centimeters. Right, even AB 15 centimeters, even GH 15 centimeters. You see that? So these are the edges that have the same length as that of EF. Okay, the last one when it comes to these edges, right, name all the edges that have the same length as FG. FG, let's do that. 1 minute. Right, returns AD is also 25 centimeters, BC is also 25 centimeters, and HE is also 25 centimeters. Okay, right. So this is very important so that we are able to find the surface area of this prism. Okay, right. Using the dimensions of each rectangle, now we know we can find any length of any of the edges there. Right, using the dimensions of each rectangle, find the surface area of the rectangular prism. I want us to do this before using the formula, and then from our calculations, we are going to come up with the formula. Okay, right. I will highlight the rectangles I want you to find the area of. Right, the first ones is just these two. Right, the area of triangle DCEF and area of triangle ABHG. But what did we say? We said that these two, did I say triangle? rectangle. If I say triangle, I'm trying to say rectangle. Right, these two rectangles are congruent, they are the same. So what you do, find the area of DCEF and then just multiply it by 2. Once you do that, you found the area of both. Let's try to do this in 1 minute. 1 minute. Right, welcome back. How do we find the area of a rectangle? Area of a rectangle is length times breadth. So now we are looking for the area of rectangle DCEF. So the length is 30 centimeters and the breadth, which is the height in this case. Okay, because we have this and this. So it's going to be 30 times 15. 30 times 15. That will be the area of rectangle DCEF. And then we just say times 2 because we have two rectangles which are just the same. So we get what? 2 times 30 times 15. 30 is the length and 15 is the height in this case. Okay? Remember, from length times breadth. Okay? All right, because if you're concentrating on the rectangle, this will be actually the breadth of the rectangle. 15 is going to be the breadth of the rectangle, but the height of the prism. Okay, so don't confuse those two. It will be the height of the prism, which is the breadth of the rectangle, DCEF. Right, now, and then I'm going to highlight the second pair, and then we do the same thing, find the area of that pair. Right, so we have rectangle ABCD and then rectangle GHEF. Let's find the area of these two rectangles. 1 minute. Right, again, ABCD is a rectangle. So the length of this rectangle, which is the breadth of the prism, is 25. Okay, remember we talked about this, 25 centimeters. And then the breadth of the rectangle, which is the height of the prism, in this case is 15. So we say 25 times 15, then times 2, because we have two congruent rectangles like that. So it's 2 times 25 times 15, which you get 750 square centimeters. So this is the breadth of the prism, then this is the height of the prism. Okay, right, then the last pair is the one at the top and the one at the bottom. Let's find the area of these two rectangles in 1 minute. Right, welcome back, greetings. Now, the bottom rectangle and the top rectangle. We have the length of the prism, which is also the length of this rectangle, BCEH. And then we have the, we have BC, which is the breadth of the rectangle and also the breadth of the prism, okay? So we have 30 times 25. But because we have two rectangles which are just the same, BCEH and ADFG, so we just say times 2. So it's 30 times 25 times 2, which is length times breadth. Length times breadth. Okay? And then what do? We add all these areas. We have two rectangles here, two rectangles here, two rectangles here, a total of 6 rectangles. So we add all these areas and then we get the total surface area of the prism. Okay, what did we say when we started? It is very easy to find the area of a prism. We find the areas of these 2D shapes which make up the prism and then we add them together. Done. You don't even need sometimes the formula because it's very, sometimes it can give you something and say the top part is not there. And then when the top part is not there, people get confused. Like we're going to talk about a rectangular prism, which is like this. Do you see this? It's a matchbox. You know, matchbox, there's something inside. But if you check this one, this part is not there, it's open. This part is not there, it's open. Then when you come to this, now people get confused. What do I do? You know that these two rectangles are not there, so it means they are not going to be included when you're calculating the total surface area of this. Okay, so now, but sometimes in mathematics we make our life easy because we have formula. So now from this we can come up with our formula. We say 2 times length times height, 2 times breadth times height, 2 times breadth times height, which is this. And then 2 times length times breadth, which is this. You see that? And then this is our formula. If you have your length, you have your breadth, you have your height. You can find the total surface area by just using this formula. But I wanted you to understand so that when you get a rectangular prism, which they'll say is open at the top, you know what to do. And it becomes very easy to understand, isn't it? Right, I would like to give you just 1 minute to make your short notes and then we continue. There is an alternative method that I want us to discuss. Instead of using 2 times length times height plus 2 times length times breadth plus 2 times breadth times height, there's another method that is very, very easy to use. So we're going to go there after your 1 minute. But take note before you write your notes. Here there's plus here. I don't know, sometimes a common mistake. You find people writing times everywhere. No, it's this plus this plus this. Please take note of that, okay? 1 minute, write your notes. Right, welcome back. Grade 10th, I want us to discuss this method or this formula because it is very, very, very essential that we know it. Because I can give you, like we talked about the hexagonal prism. Remember the hexagonal prism? Now, if we're going to say now we need to find, rectangle is going to be easy to find the areas of rectangles. But how are we going to find the area of the hexagon? You see, it's going to be difficult for us to find the area of the hexagon. So this method will assist us to find an area of what? Of prisms of the form of hexagonal what? Prisms, or pentagonal prisms, or octagonal prisms. It's very easy. So this formula, let me write it first before we describe it, or before we discuss it. It says area surface, let me use SA for surface area. SA means surface area, yeah? Of prism. You can also write it down, is equal to 2 times area of base. You know what base is. We talked about bases, né? 2 times area of base, and then plus, it's going to give us problem. This one in the base, I think, right? Plus what? Perimeter of base. Perimeter of base times height of prism. Please take note. We discussed the height of prism. Okay, this is the formula. 2 times area of base plus perimeter of perimeter of base times height of prism. Right, let's see now. Let's discuss this. So we want to find the surface area of this rectangular prism. I'm going to explain using the rectangular prism. We have these 2 bases. Okay, now I'm going to use the net here. This is called the net of the rectangular prism. So this will be the area of the base and the area of the base. So this is this part, 2 times the area of the base. And then now we're left with this center part, which is pink. Let me highlight it in pink. Right, I'm talking about this. Right, this is the base, this is another base. So now these areas are catered for. We have talked about them, the gray part. So now they've been removed. What are we left with? We are left with this thing, which is open like this. Open like this. So this part is the pink part. So we can open it like this. You see, you can open it like this. It is a prism like this, rectangular prism. We can open it like this. And it becomes, what shape is this? It is a rectangle. Do you see that? A big rectangle, right? And then, let me fold it again. Right, we have the perimeter of the base. Length plus breadth plus length plus breadth. That's the perimeter of what? Of the base. So if I open it up, the perimeter of the base becomes the length of this big rectangle. The perimeter of the base becomes the length of this big rectangle. And then, what is the breadth of the big rectangle? If it's a prism like this, we say this distance between the congruent faces is called what? The height of the prism. This is the height of the prism. So when you open it like this, we have the length of the big rectangle and the height of the prism. So the perimeter is the length of the big rectangle. The height of the prism is the breadth of the big rectangle. So you can find this area by saying perimeter times height of prism. Does it make sense? I really hope that it makes sense. Let's come back to our diagrams. Maybe they will also assist us. Right. So we say that we have this distance, or the mesh box here. So we have the perimeter of the base. The perimeter of the base. Let me highlight it. Let's look at base ABCD. Base ABCD. Okay, that's the distance around ABCD. Okay, which is the same as this. Let me highlight it on the mesh box there. You see that? Then when you open it up, it is the same as this distance from there up to there. Which is what? Which is going to be 15, because this is 15, 25, 15, 25. So it's going to be 15 plus 25 plus 15 plus 25. Our net is not drawn to scale, so don't worry. Right, so it's 15, 25, 15, 25, which is now the length of the big rectangle. And then the height of the prism, which is the distance from there up to there, is going to be 30 centimeters. You see that? And then we can find the area of the big rectangle, the pink one, which is perimeter of the base times height of the prism. That's the formula. This formula will assist us a lot. If you remember it, we are going to be enjoying mathematics. We are going to enjoy mathematics. Remember this formula. Right, so what we do, we say, we find the area of the two bases. We find the area of the two bases, which is AB, CD, and GHEF. So we say 2 times 15 times 25, because this is 15 times 25, this area, 15 times 25, okay? Right, I'll give you time to write notes, maybe 2 minutes, because I think I've been moving fast here. Right, and then that's the area of the two bases. Now we're left with this part. We're left with this part now. You see this part? Area of the two bases done, 750 square centimeters. This part now, we say the perimeter of the base times height of the prism. Perimeter of the base times height of the prism. We added those perimeters, they say 15 plus 25 plus 15 plus 25, or just 2 times. Remember, perimeter of a rectangle is 2 times length plus breadth. So you say 15 plus 25, which is 40, and then 40 times 2 is 80. So perimeter of ABCD is 80 centimeters. Okay, we say this will give us 40 times 2, then we get 80. Now, and then the height of the base is 30. This is the height of the base. Multiply the perimeter of the base with CE, which is the height of, just the height of the base. So I've been talking a lot. Height of the prism. Right, perimeter of the base with CE, the height of the prism. The height of the prism, sorry for that. So we multiply these two. How did it move? Okay, I want us to just have short notes up to here before we continue. Let me give you 1 minute for this slide, then I'm going to give you another minute for the other slide. Just short notes, 1 minute. Right, welcome back. So now this is the area of this part. Now it's basically the area of the lateral faces. Remember we talked about the lateral faces. This will be the area of the lateral faces. How do you find the area of the lateral faces? Is the perimeter of the base times height of the prism. Just that. Perimeter of the base times height of the prism gives you the area of all the lateral faces. Instead of doing them one by one, just perimeter times height of the base, you have the area of your lateral faces. Now we have the area of the lateral faces and the area of the two bases. We add them, and then what do we get? We get 3,150 square centimeters, which is similar to what we got when we used 2 times length times breadth plus 2 times length times height plus 2 times breadth times height. We got the same area, isn't it? Okay, and then the formula is this formula. So you can write it down in 1 minute, and then after this I'm going to give you a good and a nice activity that you're going to do. Let's try. Notes for 1 minute. Right, welcome back. Now let's go to the activity. Don't worry, it's going to be a very easy one. Okay? Given triangular prism ABC is an isosceles triangle. Let me give you a clue. It means this one is going to be 50 centimeters in an isosceles triangle. Right, calculate the total surface area of the triangular prism by calculating the area of each 2D shape in the prism. Okay? Right. Maybe because of time, let me do this. Because of time, let me explain this, okay? Let me explain. I know you want to do your activity, but we're left with 7 minutes. Let me explain this, and then I'll give you time to write notes, okay? Right, so what we can do here, we want to calculate the surface area by finding the area of each 2D shape. So we have two triangles, isn't it? ABC and DFE. So how do we find the area of a triangle? We say half times base times height. Our base is 60, our height is 40. The height of the base, not the height of the prism. The height of the prism is CE, which is 80 centimeters. So here we're using the height of the base. So it's going to be area of two triangles is 2 times, because there are 2 of them, 2 triangles. 2 times half times 60 times 40. And then we get 2,400 square centimeters. This is the area of the 2D, of the 2 triangles, right? Now, we can find the areas now of the 3 rectangles, which is going to be 80 times 50. Which rectangle is 80 by 50? We have rectangle ACED. Do you see rectangle ACED is 80 by 50? And then we have also rectangle ABFD. ABFD. Let me just ABFD. Right? It's another rectangle which is 80 by 50. And then we have the bottom one, the one at the bottom, which is rectangle BCEF. BCEF is 80 by 60 or 60 by 80, which is this one. You see that? So it's first rectangle plus second rectangle plus third rectangle. And then we get 12,800 square centimeters. Now this is rectangles only. And then what we do, we add the area of the triangles and the area of the rectangles. And then we get 15,200 square centimeters. Let's write our notes for 1 minute. Right, welcome back. Now our method, the second one, what did we say? We said we find the perimeter of the base, and then we say perimeter of the base times height of the prism. That will just give us the area of the lateral faces. In this case, all the 3 rectangles. Okay, so it will be the area 2 times area of the base, then plus perimeter of the base times height of the prism. Just that, and then we're done. Let's do that. So we're going to calculate the total surface area of the triangular prism by calculating the area of the 2 bases and that of the lateral faces. I don't know what this box misbehaved here. Just went up and closed my words there. Right. The area of the 2 bases and that of the lateral faces. What we do then? We say area of the two triangles, which are the bases, and then perimeter of the base times height of the prism. Are we going to get the same answer? Let's see. So it's going to be 2 times half times 60 times 40, which is the area of the two bases, which are triangles in this case. And then the perimeter of the base is 50. Remember, we said this is also 50. 50 plus 50 plus 60. And then times height of the prism, which is this. And then we add these two, this part and this part. We add them. Then what do you get? Are we getting the same thing? Do you see that we're getting the same thing? Okay. All right. Now we have managed to explain the second part. I'm going to give you 1 minute to write your notes, and then after 1 minute we will take a short break, and then after that break we're going to go to our homework and summarize our lesson. Let's have 1 minute for our notes.
The road to success is to commit to yourself. In order for you to become who you want to become as a student, you need to commit to reading your books, to studying, to bettering yourself. I know it's not going to be easy. Actually, no one said it's going to be easy. But if you put in the work, the results will show in your life. Tap into your power. Sometimes you will feel like putting away your books, and not reading as much as you're supposed to be. But I want you to commit, because through commitment, there is infinite power.
Right, welcome back. Grade 10, this is your homework. You know how you copy your homework. If you pause the video and take a screenshot, pause the video and write your questions, whichever way you're comfortable with, let's do that. And then after that, we're going to move to our summary. Just let me give you 1 minute on this, and then after that, we're going to go to our summary. Right, let's finish our lesson, grade 10s. We didn't discuss a lot. I'm encouraging you, grade 10s. Let's discuss, let's interact during the lesson so that we learn. Don't be afraid. Don't be afraid. Ask your questions. We are here waiting for your questions, okay? I really hope in our next lesson, we are going to interact more. Right, summary. The surface area of a right prism is the sum of two D shapes that make up the surface of the prism. We saw that in our lesson. And then the total surface area is 2 times area of the base plus perimeter of base times height of the prism. We also managed to use this formula. And then surface area is expressed in square units. Please take note of that. And then volume, we didn't manage to go to volume, but volume of a prism is area of base. We know what a base is times height of prism. Okay, and you know what the height of prism is. You may use this in your other lessons. Right, thank you very much, grade 10s. We're going to meet next week. Remember, we meet every Thursday, 9 a.m. Let's meet here and we do mathematics. We're going to meet next week. Goodbye.